In this lesson, we are going to discuss virtualization and containerization. Virtualization is a powerful technology that allows for the emulation of servers, each running its own operating systems within a virtual machine. Containerization is a lightweight alternative to full machine virtualization that involves encapsulating an application in a container within its own operating environment. In this lesson, we are going to cover both virtualization and containerization, the benefit and the risks of both, some vulnerabilities that threaten your virtual machines, and how to secure them. Virtual machines operate on a platform known as a hypervisor, which manages the distribution of the physical server's resources, such as the processor, memory, and hard disk space, among the virtual machines. Hypervisors come in two main types, Type 1 and Type 2. A Type 1 hypervisor, also known as a bare metal or a native hypervisor, runs directly on the host hardware and functions similarly to an operating system. Examples of Type 1 hypervisors include Microsoft's Hyper-V, Citrix's XenServer, and VMware's ESXi and vSphere. On the other hand, Type 2 hypervisor operates within a standard operating system, such as Windows, Mac, or Linux. An example of this can be seen in the next lesson, where Windows 10 will be installed as an emulated desktop computer inside a virtual machine run by VirtualBox software on a Mac OS X desktop. This demonstrates the versatility of Type 2 hypervisors like VirtualBox and VMware, which allow for the operation of different systems within another. However, it's important to note that a Type 1 or bare metal hypervisor is generally faster and efficient than a Type 2 or hosted hypervisor. This is because a bare metal hypervisor does not spend the physical computer's resources running a full desktop operating system first. Instead, it acts as a streamlined, specialized operating system to provide the physical resources to the virtual machines it hosts. Containerization, on the other hand, is a lightweight alternative to full machine virtualization that involves encapsulating an application in a container within its own operating environment. This provides many benefits of loading an application onto a virtual machine, as the application can be run on any suitable physical machine without any worries about dependencies. In simpler terms, containerization is a method of running applications in isolated user spaces called containers. These containers are separated from each other but share the host system's OS kernel. Each container includes the application and all of its dependencies. However, it shares the OS and usually the binaries and libraries from the host machine. This approach offers several advantages, including efficiency and speed, portability, scalability, isolation, and consistency. Popular containerization technologies include Docker, Kubernetes, and Red Hat OpenShift. These technologies have revolutionized the way developers and organizations create, deploy, and manage applications, particularly in cloud environments. While virtualization brings with it a lot of capability to add separation inside of our servers and bring in some additional security, there are some unique vulnerabilities that can be exploited by attackers when it comes to virtualization. These can include VM escape, privilege elevation, live VM migration, and resource reuse. Virtual machines are segmented and separated by default, so if an attacker is able to exploit the operating system being run inside one virtual machine, it doesn't necessarily mean that they can get on the other virtual machines being hosted by the same physical server. Virtual machine escape or VM escape occurs when an attacker is able to break out of one of these normally isolated virtual machines and they can begin to interact directly with the underlying hypervisor. From this position, the attacker could migrate themselves out and into another virtual machine being hosted on the same physical server. Now, VM escape techniques are extremely difficult to conduct. They rely on exploiting physical resources that are shared between the VMs, but it's still a vulnerability that you need to be aware of. To mitigate this vulnerability, virtual servers should be hosted on the same physical servers as other virtual machines in the same network or network segment based on its classification. Privilege elevation occurs when a user is able to grant themselves the ability to run functions as a higher level user, such as the root or the administrator. While this can be bad on a single server, It can be catastrophic on a physical server if the attacker is able to perform this on the hypervisor itself. A few years ago, VMware had a flaw on their hypervisor that allowed a user to escalate privileges into any of the guest operating systems hosted by that hypervisor. To prevent this, it's important to remain current on your hotfixes and your service packs for your virtualization software. Another vulnerability to consider is one associated with live migration of virtual machines. When a virtual machine needs to move from one physical host to another, this is called a live migration. If an attacker can gain a foothold into your network and place themselves between these two physical machines, they can implement a form of an adversary in the middle attack, where they can capture the data being sent between two physical servers. If this data has not been encrypted, this can allow the attacker to breach the confidentiality of the servers being hosted as virtual machines when they're transmitted over the network. Finally, resource reuse. Resource reuse is a concept in computing where system resources like memory, storage, or processing power can be reused for different tasks or processes. While this is an efficient way to utilize resources, it can also introduce a type of vulnerability known as a resource reuse vulnerability. A resource reuse vulnerability occurs when a system resource such as memory is not properly cleared or reset before being assigned to another task. This can potentially allow sensitive information from the previous task to be exposed to the new task. This type of vulnerability is particularly relevant in multi-tenant environments like cloud computing, where resources are shared among multiple users. If a resource reuse vulnerability exists, one user might be able to access sensitive information belonging to another user. Finally, when we're specifically relying upon application containerization as our virtualization method, it's important to realize that the containers are all sharing a single common operating system. If the attacker is able to exploit that one operating system through some vulnerability, this causes all of the applications being hosted on that operating system to be at risk. So now that I scared you with all the threats that exist on virtual machines, let's talk about how you can best secure them. Most of the things that we need to do to secure a virtual machine are very similar to things that we need to do to secure a regular physical server. This includes things like updating your operating systems and your applications. Also, you need to ensure that each virtual machine has a good antivirus solution installed, with its own software firewall, good strong passwords, and good policies, and all of other security features that we're going to discuss throughout this course. First, remember that a hypervisor, whether it's a Type 1, Type 2, or application containerization-based model, needs to be updated and secured whenever the manufacturer releases a new security patch. For example, if an exploit has been discovered that you can now conduct a VM escape against VMware, you can be certain that a company like VMware is going to quickly release a patch to fix this critical vulnerability. In managing virtual machines or VMs, it's crucial to limit the connections between VMs and the physical machines, which can be represented by a virtualized network card or network shares. If a VM gets infected with malware, it should remain isolated from other VMs hosted by the same hypervisor, provided the isolation configurations are correctly implemented. Connections between a VM and a shared resource, such as a network file server, can potentially allow data to be passed between different VMs, breaking down the isolation. Therefore, it is advised to minimize and remove any unneeded features to support operations, reducing the attack surface and potential vulnerabilities. If an attacker compromises a VM and forces it to use a large amount of physical server resources, it can affect other VMs hosted on the same server, potentially resulting in a denial of service. To mitigate this, consider distributing your VMs among several physical servers. As a system administrator, it's important to track your VMs and ensure that they are properly patched and up to date. Be aware of virtualization sprawl, where VMs are created and deployed without proper oversight, making it easy to lose track of them. Lastly, enable encryption of the file that hosts the VMs to ensure safety and confidentiality. This protects the VM files from unauthorized access on the server. So remember, virtualization is a technology that allows for the emulation of servers, each running its own operating system within a virtual machine. Containerization is a lightweight alternative to full machine virtualization that encapsulates an application in a container with its own operating environment. Hypervisors come in two types: Type 1, or a bare metal hypervisor, and Type 2, or a hosted hypervisor. Type 1 hypervisors are generally faster and more efficient than Type 2. Virtualization vulnerabilities include VM escape, data remnants, privilege escalation, live VM migration, resource reuse, and VM sprawl. Securing virtual machines involves updating the operating systems and applications, installing antivirus solutions, implementing software firewalls, using strong passwords, and applying security patches for the hypervisor.